Hello, welcome again. We are covering the subject thermodynamics for civil services, mains, IFS, and various gate exam. The next topic in the chapter of properties of gases and mixture is specific heat, internal energy, and enthalpy of an ideal gas. So we have from the property relation that is TdS is equal to du plus PdV. That we know. And dividing T both sides will be ds is equal to du by T plus P by T d. So this is equation number 1. So now we can assume u as function of temperature and volume. Okay, and then thermodynamic. Then from thermodynamic relation chapter, we can write this u as du is equal to curly u by curly t v constant into dt plus curly u by curly v t constant dv. So this is equation number 2. So now if we compare 1 and 2, sorry, if we put the value of du from 2 in 1, then the equation number 1 will become ds is equal to, so we are putting du here, ds will be equal to 1 by t is t curly u by curly t v constant dt plus 1 by t this t with curly u by curly v t dv plus p dv, and now we can take dv as common, so it will be 1 by t bracket curly u by curly v t plus p bracket close dv. Okay, so now again we can assume entropy as function of T and V, so ds can be written as, now we'll compare this with this equation. So we can write ds curly s by curly t v constant into dt plus curly s by curly v t constant to d. So now here dt is there and here dv is there and here also dt is there and dv is there. So and here on the left hand side both in the both equation ds is there. So this will be equal to this quantity. So curly s by curly t v constant is equal to 1 by t curly u by curly t v, and this will be equal to this quantity. So here curly s by curly t, sorry, curly s by curly v t constant is equal to 1 by t curly u by curly v t constant plus p within bracket. This is equation number 2. So now if we differentiate this equation 5 with respect to v and differentiate this equation 6 with respect to t, then we'll get curly square s by curly t v. If we differentiate 5, then in the right hand side we will get 1 by t curly square u by curly t curly v. So it's equation 7, and if we differentiate 6 with respect to t, we will get this. So it will be 1 by t curly square u curly with t plus 1 by t curly p by curly v. First differentiating this quantity using product rule, and now differentiating this t. 1 by t square curly u, keeping this thing, 1 by t square curly u by curly v t minus p by t square. So now we can equate 7 and 8 because left hand side of both are same. So equating this, we get this equation. Curly u by curly v t constant plus p is equal to t curly p by curly t v. So this is equation number 9. Okay. So now from this equation we'll if we apply it to the ideal gas, then PV is equal to RT and V curly P by curly T V constant is equal to R, and curly P by curly T is equal to R by V, and R by V from this is equal to P by T. So this is equation number 10. Now we put it in the 9, then we get curly u by curly v t constant as 0. So this for an ideal gas, internal energy is not the function of volume. Okay. And It is a function of temperature. So temperature is constant and it is zero. Similarly, it can also be proved that curly by curly p t constant is equal to zero. Okay. So it is only the function of temperature. This is your Joule's law. Okay. So now, if now if we assume that u is function of t and b, then du is equal to curly u by curly t v into dt plus curly u by curly v t into dv. Okay. And we have this curly u by curly v t is equal to 0. Here we have got this, but now, but we know that curly u by curly t sorry du is equal to cv dt. So this will be your cv. So curly u by curly t at constant volume is your cv. So du is equal to cv dt for ideal gas. Okay. So this will be your cv. So du is equal to cv dt, and now we have enthalpy is equal to h is equal to u plus cv, and pv is equal to rt. So h is u plus rt. So this is your t, this is also the function t, so h is function of t. So dh is your du plus r dt, and del h is equal to du is your cv dt, cv del t, and this is your r del t, or we can write it as del h plus del h is equal to cv plus r del t, and cv plus r is your cp. So that is called specific heat at constant pressure, that is curly h by curly t at constant pressure. This is your cp. So this is valid for idle gas, then cp minus cv is equal to r, and cp by cv is your gamma, and from these two we can get cv is equal to r by gamma minus 1 and cp is equal to gamma r by gamma minus 1. Okay, and again this r is your characteristic gas constant, that is equal to universal gas constant by molecular weight. Similarly, cv molar is your molecular weight into cv, and cp molar is your molecular weight into cv. Same way. Okay. This is universal gas constant is characteristic gas constant into mu. So molar cv is molecular weight into cv, characteristic sorry specific heat at constant volume in kilojoule per kilogram per degree Kelvin, and this is your molar cp, that is equal to mu into c.